Alright, so the first topic we're going to cover in class here is SI units, or scientific units, and the metric system. So these two are intertangled. Pretty much the metric system are scientific units. There's a few differences here and there, but for the most part, they're the same. And the metric system gets applied with those units, so maybe we have a weird unit for energy that we use, but we can still use the metric system prefixes, which I'll talk about, even though it's not the standard metric system unit. Okay, so units are what we use to measure something. So there's like, an object, like say this little tuk-tuk here. This is like, because my dad got this for me in India. I don't know why. It's being driven by either escaped convict in an orange suit or someone who definitely works out at the gym and is proud of their arms. I'm not sure which. But anyway, if I want to know how long this was, or maybe, how far it travels, I can use units to describe that. If I go, oh, it went a piece of paper, yeah, that could be a unit, but maybe I could, use a tape measure and get a measurement on that. Be a little bit more exact and convey that information to somebody else who isn't, present to see what's going on. So, and we'll get into that more in a little bit. But first, SI units, the units that we use, for scientific stuff. So there's a couple things we can measure. One of them is length. We can also measure volume. We can measure mass. We can measure time. We can measure energy. And then lastly is temperature. So these all have different units, You don't say it's 100 feet outside, right? You say some unit of temperature. You say like degrees, Fahrenheit, or Celsius if you're in the rest of the world. Or if you're a scientist, you say Kelvin. But we'll get there in a minute. So the SI units for these different properties are the following. So length, we use meters, which is, that's just a metric system for length. It's about 3 feet. A yard and a meter are very close. They're just a couple inches apart. And we abbreviate that with an M. So that'd be, something we would do. I'll talk about prefixes a little bit. Maybe we're not dealing with 3-foot chunks of space at a time. Maybe it's smaller, maybe it's larger. So you get things like kilometers or centimeters. And then for volume, we use liters. So, turns out the most scientific thing in your grocery store is soda, because it's sold in liters. So there you go. Unlike that dastardly milk, which is sold in gallons, whatever those are. And then we've got mass, and our unit for mass is grams, which we abbreviate with the lowercase g. Hope you guys enjoy my handwriting, by the way. I'm actually better at writing on a board than paper, but the times we're in, And then time, technically it's seconds, but depending on what you're doing, could be more time or less time. We might be talking about milliseconds, or we do minutes or hours. It scales up. If you're a geologist, you're talking about epochs, so tens of thousands of years. You don't want to try to calculate that in a second. So there's some flexibility in these. The SI unit for energy is calories, but joules do come up from time to time as well. It has weird stuff too, like ergs, whatever those are. We abbreviate that CAL. And lastly, temperature is in Kelvin. This one gets capitalized because it's actually named after somebody. Lord Kelvin of the cold. I don't know if that's actually his title, but he was Lord Kelvin. And so Kelvin is a scale that goes all the way to 0. So 0 is the coldest something can be. Whereas, Celsius, you can have a negative temperature in Celsius. Fahrenheit, we definitely can get negative. Water freezes at 32 in Fahrenheit for whatever reason. Whereas it freezes in 0. In Celsius, it boils at 100. So Celsius is a temperature scale built around water. But you can get things colder than the freezing point of water. So you can have a negative temperature. Same with Fahrenheit. You can get things colder than 0 degrees Fahrenheit. So you can have negative temperature in Fahrenheit. But Kelvin is something where it has what we call absolute 0. That is as cold as something could be. You cannot have a negative temperature in Kelvin. By definition, you'd have less than 0 energy in it. We don't tend to have negative energy. So that can change. So these are all of our SI units right here. And we can kind of compound these a little bit, or add on to this idea, with the metric system. Alright. And so this is a system of prefixes. And so, we start with the ones place here. And, that would be something like meters or liters or grams. We don't have any prefix for that, so there's no prefix. But as we move out, so we can go to the tens place, the hundred, the thousand, and the million. But we can also get smaller. So we can go to the tenths place, or the hundredths place, or the thousandths place, or the we got the millionths place. So it's going to be 1, 2, 3, 4, 5, and then a 1. Yeah, look at that, clean right there. Okay, so we can have different prefixes. So if I'm dealing with tens of something, I call that a deca. Carry that line down. So I could be talking about decameters. Like if something's 30 meters away, I could say, well, it's 30 meters, or I could say it's 3 decameters. Or if there's 100, we call that hecta. Oops. No eraser on a Sharpie, right? So that's, hecked a lot of stuff, right? Or perhaps more commonly, 1,000, that's kilo. So turns out we tend to talk about distances in kilometers. If you're like, oh, how far away is Portland? Well, this is America. We use our freedom units, so we talk about it in miles. But the rest of the world would use kilometers, including Canada. So you don't have to go very far to see this. And they would use kilometers. They wouldn't say that it's 50,000 meters between two locations. They just say it's 50 kilometers. So they knock it down. So we don't have to write as many numbers. We don't have to say things like thousands. And then if you get to millions, this is, mega. And all of these have a shorthand abbreviation. Deca is DA. Hecta is H. Kilo is K. Mega is M. And these two right here aren't used a lot. It tends to just jump in the thousands. You'll notice after kilo, we always just go up by a factor of 1,000. And if you think about computers, you might be able to guess where it goes next. Like you have megabytes, first you had kilobytes, then you had megabytes, and then gigabytes, terabytes, and then we're going to get into petabytes eventually. And they all grow by a factor of 1,000. So it's only around the decimal points there, about the ones place, that we have these smaller changes. And so if we go the other way, a tenth is a deca, D-E-C-I. That's just a lowercase d as abbreviation. 100th is centa. That's just a C. 1,000th is milla. That's a lowercase m. So mega is a capital M. Milla is a lowercase m. And then we have micro is 1 millionth. And that's a mu. Alright, and it can keep going lower, just like it can keep going up. Like mega leads into other prefixes, and that's a mu if I didn't say so before, so that's a Greek letter. Sometimes you might see it look like that, which is obviously a U with a sinus infection, is how I describe it. But I prefer the more swirly M-looking thing myself. But either of those is just a font difference. But you can go micro, and then it goes nano. Yeah, basically you work your way back through the old iPods. Like you had the iPod Micro, and you had the iPod Nano, and it just keeps going and going and going. And you get smaller and smaller, and it jumps 1,000th of what the previous one was. So micro is 1 millionth, nano is 1 billionth, and so on and so forth. And so we can look at this and we go like, oh, I could have 1 meter. Or I could say that that's 100 centimeters. You know, and where this is really beneficial is, well, what if I have, a tenth of a meter? Well, I could say I have 10 centimeters. Or if I'm dealing with large numbers, I could have something like 2,000 meters, and that is the same as 2 kilometers. So it just lets us write less. Look at all that writing I had to do. I got to save myself time, I got to save myself Sharpie ink. It's a win-win all the way around. And so this is kind of the first introduction. We're going to talk about unit conversions next, so we're going to use these metric system conversion, the system to convert between different units. So I just wrote them out, but we're going to talk about a more formal way of doing this mathematically to help avoid error. So this will be the format of my videos throughout the class. I don't have a whiteboard at home to work off of. My preference would be to film myself in front of a whiteboard, but this is what we'll be doing instead. So this will be a stack of paper that I work my way through, pitch it aside when I'm done with it. But that's it for this video. All the rest of them are going to be this kind of style. So hope it's working for you. If there's anything I can do better, just let me know. If you have any ideas, I'm all ears. I don't have a ton of online teaching experience, so I am very open to suggestions. Alright, so welcome to class. And so next we are going to talk about unit conversions. And like I said, we're going to make use of what we just talked about a little bit. I do expect you to know how to use the metric system, so we are going to talk about that a little bit more in the next video, and how to apply those prefixes, but you are expected to know those. And I guess one point I should make, don't know if it was super clear, was we just use these prefixes, like a c, lowercase c, in front of whatever our unit notation is. So those are centimeters, centimeters, K for kilometers, so on and so forth. Alright, so on to the next video.